So good morning or good evening, wherever you are. Thank you for joining us for our presentation on our tool, Message Broker Precise for SonarQube. So I just popped up a little bit of agenda. We'll be looking to go for about an hour. So we're going to talk about a few things. What we're trying to achieve with trying to improve code quality and why it's important for the business. What some of the things that we describe code quality as, or encompass code quality, and then we'll go through a demonstration of the products and some of the features, and finish up with the drawing and the way forward, or the future sort of features we're looking to bring out. So what is it we're trying to achieve with this product, with SonarQube and with our plugin? In a nutshell, what we're trying to do is write cheap code. So cheap means different things to different people, and I don't mean finding the cheapest developers you can find that will work for the minimum amount of money and locking them up in a dark room and not providing them with heating. What I mean is we want to write code that does what the business requires and is easy to understandable and as performant as we can get it. So when I say it's easy to understand, what makes it easy to understand makes it easy to change, and the easier it is to change and understand, the less likely you are to have bugs. The fewer bugs you have, the less it costs for the business, because when you have bugs, you can either have performance issues related to bugs, or you might have inappropriate or inconsistent results to customers or whatnot. So if you mess up an interest rate on a swap or something like that, you could actually cost a lot of money, which suddenly makes your software very expensive to run if it's mispricing things, for example. So what I mean by cheap: bug-free, can be understood, performs well, can be changed, and can be tested. So we're talking about tested. So some of the new, development methodologies around test-driven development, behavior-driven development, where we encompass our business teams with our developers and our testers. So we wind up writing test cases and behaviors first, and then developing code that perform and essentially provide those behaviors. You can't do that without being able to test code. We'll get into test coverage a bit later. That later being now. So we're talking about test coverage. So we're talking about test coverage. We're talking about how much of your code has been tested in some sort of automated way. This is important because it gives us a bit of comfort that the code's likely to do what we've said it's done. So if we develop a test case with the business, and we can show that test case running, and we can show that our code coverage is executing, and that a certain amount of our code is being covered by the test case, we have a comfort that the results we're getting are fairly thorough. The other thing about that is the more test coverage we got, the more able we are to be able to make changes and restructure, organize code, rerun our tests, and be comfortable and confident that we haven't introduced other bugs. Without test coverage, it's very difficult for us to get a high velocity of change on our projects, because we have a lot of fear about changing things and breaking other things. So there's a few references here about how we get good code, and then I'll just open up a few and talk quickly about them. So we talk about the 7 deadly sins. This is actually from the SonarQube site. We talk about bugs and potential bugs, or we call them violations. We'll get to that in the demonstration. So basically, that's looking for patterns or anti-patterns of development which are buggy or likely to cause bugs. Code breaching standards or code standards. So where we're talking about making code easy to understand for developers, we're talking about making the code consistent. So code may be complicated, but we're writing it in a consistent way, so that the next developer that comes and tries to make a change to the code or understands the code, it's a lot easier for them to do it, and they're a lot more intelligently able to comprehend what the code's doing, because it's written in a consistent way that they're used to. And that consistency gives the developers and teams a bit more of a chance at a higher velocity of change, because every time they have to revisit code, they're not re-understanding something. They're not relearning the language that each individual organization has about how they have to write code. Duplications, so we're talking about avoiding duplications because it creates maintenance issues and potential issues with bugs. So if we have something, for example, that it calculates interest rate, we probably want that to be only one place. We don't want to have to change 5 or 6 places or code in 5 or 6 places if, say, an interest rate changes, because the chances are, particularly without good code coverage, is that if we miss one of those places, we might get spurious results somewhere else in some other part of the system that we're not really looking to change. It also means that we want to tune, if we want to tune a particular piece of code because we want it to perform well, if we only tune one of the places that interest rate calculation is in, then we might not get the full benefit because some of the other places or some of the other copies of that code might not be tuned. So lack of unit testing, I was mentioning before, if you can't test something, you're not confident that it works, so you can't really be confident you can change it without having to regression test a lot of code. Bad distribution of complexity. So if we've got complexity all over our code, it can lead to having code that's difficult to understand and difficult to test. And comments, if you're not putting comments in your code when it makes sense to, then it can make it difficult for the next developer to follow if the comments provide some sort of useful business insight of why something is. And the reverse is also true. If you put too many comments in your code and the comments become as much of a maintenance nightmare as the code itself, you end up getting the comments in the code out of sync. And a lot of people will say that comments that aren't valid are actually worthless. Whether or not I agree with that, to some extent I do, but you don't want comments in code that are inconsistent because it just adds confusion for the developer. So that's the 7 deadly sins that we're looking to capture with, particularly with Sonar, and on top of that with our MB Precise plugin. Does anyone have any quick questions before, or long questions before we move on? Right, so we talked about deadly sins. We talked about unit testing. I'll just open up the reference here to the unit testing. And so all these URLs, if you are interested, are on the agenda that you would have received when you signed up for the presentation. Oh, what I might do is to move on because we've sort of been through unit testing. So find bugs. So when we talk about our product, we say that it's like find bugs, PMD, and find bugs, checkstyle, and PD. Find bugs, checkstyle, and PMD, but for message broker. So find bugs and PMD are quite similar. PMD has some extra functionality around checking of duplications, but essentially find bugs is a Java tool which was sort of synthesized in the message broker world that looks for common programming issues, whether it's something to do with threads or unused variables or objects, variables potentially not assigned, those sorts of things, or illogically assigned. And there's a whole plethora of bugs that find bugs in PMD check for, but essentially we're trying to synthesize as many of these types of bugs because these are fairly common sort of bugs across any number of programming languages, and that's what we're trying to do. We're trying to write code that's bug-free, that's easy and understandable, and performs and is bug-free, so it doesn't give their businesses any additional dangerous costs. So Checkstar, another product from the Java world that we've sort of synthesized, where and Checkstar's not so much about the logic of the code, but more the style, how the code's laid out, how the variables are named, how the functions are named, how the comments are defined, where the comments are, and so on and so forth. So it's attempting to help you or assist you in making your code as consistent as you can without knowing what the code's doing. PMD, as I mentioned, is like find bugs. It's some common sort of bugs, potential bugs and bugs that it checks for. But the interesting thing here that's worth noting or worth discussing is that it does copy-paste detection, and that's one of the 7 deadly sins, and that's one of the things that quite often is difficult to pick up in a code review, but it's quite easy for compilers and tools like that to pick up on it, because they're quite good at crunching large amounts of code across lots and lots of different files. So technical debt is a term introduced by Martin Fowler, and what it is it's a measure of how many things you've identified that are bad in your code. So the code may work, but you might say, well, it's not written in a way that's easy to understand or easy to maintain or easy to change. So what sort of things are bad in your code that makes it hard for you to change it? So what we're saying is it will be, if we eradicate as much of our technical debt as possible, our future enhancements to our code actually take less time and cost less money to do, with the theory that the larger amount of technical debt that you have, the slower it becomes to create new features and make new changes. So, for example, if you have a routine that's got 15,000 lines in it, and someone has to read and understand all 15,000 lines of that procedure or that method to be able to make changes to it, it's very difficult to make changes to that code, because there's lots of different permutations and lots of different things that you could break without knowing everything in the code. While if you create good abstractions and you have small blocks of functional code that do one specific job, then it's very easy to change those abstractions or those particular interfaces or those particular modules without affecting anything else or adversely affecting anything else. So one with a large amount of technical debt is very difficult to change. The one with a small amount of technical debt, in theory, is easy to change. So technical debt is just a measure that we try to assign to our code, where more technical debt is bad. So continuous integration is a practice where all the developers' codes integrated on a regular basis to make sure that it works with the other developers' code and other teams' code. This is So this is important, because what that means is that we can do unit testing and testing and things like that, because the more often we can integrate our code, the more often we can run it as a combined unit, and the more easy it is, more likely it is we'll find issues where different components connect together. And so I mentioned continuous integration in this presentation because when we're talking about SonarQube and building quality profiles and quality pipelines that we'll talk about later, that sort of relies on being able to continuously integrate code from version control system, continuously deploy or continuously build the code, continuously check the quality of the code, and continuously deploy the code, make the code ready for businesses to use. And which gets us onto continuous delivery. So what we're talking about continuous delivery is having code in a state where we can deploy it to into either for example, a test environment or a staging environment, or even a potentially production environment regularly, and almost, not so much instantaneously, but almost any time during our project. So what this means, or what we want to do, is when we write and develop our code, when we check it in, we want to have all our quality and all our regression testing and whatnot built into our process, so that when we have code checked in and builds, we're pretty confident that that code is actually almost ready to be deployed to either for a business person or a tester to test, or even potentially a customer to use. And there's different sort of steps we have to put into place, or different strategies we have to take on to make that something that's can be done. Snowflake setups, again, I believe coined by Martin Fowler. And Snowflake setups is talking about where every time you deploy or release a piece of code into a different environment, you end up with slightly different, end up with a slightly different permutation of your artifacts and slightly different configured artifacts, so that you end up having to do a lot more testing every time you go to a different environment. You end up with different behaviors in different environments. And I mentioned here because we do have some checks in our product that try to minimize or try to detect when things are actually potentially going to change from environment to environment, because they're not consistent in the static code analysis. And the last one's just a developer works article around just how this can be built up and how this is built up. It's like a DevOps process. Now, does anyone have any questions just while we finished off the going through those points? Oh, so no questions, so I'll keep moving on. So that's what we're trying to achieve, and there's the reasons we're trying to achieve it. So we'll jump into the actual demonstration. So what we're looking at here is something called the SonarQube dashboard. So the SonarQube product is made up of two components, or three components, but usually just say two. So it's made of a database, which records things called metrics and violations in code, and it records them over time. So what that means is that if you run this SonarQube analysis against your code, or you run an analysis using SonarQube that picks up other reporting information such as test code coverage, it will actually track that and put that in the database so that when you run it again tomorrow, it's got something to compare with from the previous day or the previous week or the previous month. And what that means is that you can build up an idea of whether your code's improving, how much it's improving by, or how much it's degrading by. So this gives us our timeline of see what our code looked like last week and what our code looks like today. The other side of it, or the other component, is the dashboard, and this dashboard is just a web GUI on top of this database, and so it gives you a bunch of information at your fingertips about your code and your code quality. And the third component is, which I'll just bring up here, is when you run an analysis, it's the interface or the tool between either say Ant or Maven or what's called the Sonar Runner that integrates with or records the information in the database. So it's like, could be a REST API. In some cases, it could be a REST API. Otherwise, it's a proprietary API from getting code from your desktop or your build server into this SonarQube database. Okay, so we're talking about code quality. We're talking about what's in the SonarQube database. So we can look up here on the left, top left, we've got some things called message broker specific metrics. So SonarQube allows you to record metrics about your code, and that metric could be the number of files, number of lines of code, the number of modules. In this case, we've developed some ESQL and Sterling particular metrics. So we've got the number of nodes. So this gives us an idea of how big our code's getting, not necessarily good or bad, it just gives us an idea of what our code's doing. So the nodes, the input nodes, the HTTP input nodes, the SOAP input nodes, the SOAP request nodes. This is just some general information. So if you have a project where you generally don't use a lot of MQ, you might want to take note of how many MQ nodes you have, because if they're getting a lot more, then you might need to address why they're coming in, or you might need to change your architecture. The one here that I would highlight is the RCD nodes. As historically they've always been a little bit of a performance issue, so we like to track them. So if you suddenly start getting a growth in the RCD nodes in your project, then you might want to look at where they're coming from and whether there's an alternative to using them. Flow length is a useful measure. So what we see here is, and I'll just open up my toolkit, but what the flow length is just an ordering. It's a list of all the flows in the code that's been analyzed in the project, and it's giving it a summary by length. So in this case here, it's saying this particular flow here is the longest one in your entire system, which is 4. Doesn't mean much, but it gives you that feedback of, well, where is my complexity and potentially where is my performance issues. So maybe not a great example with a flow length of 4, but if we go, if we look here and we've got a flow length of, if we look here and we've got a flow length of 10, we can see that flow seems to be considerably long. In that case, we might want to look at what that flow is actually doing and whether or not we need to break it up for performance or manageability or maintenance reasons. Again, this particular number is a metric. It's not necessarily good or bad. It's just an indication or something that you may want to look at. We've got these things called you've got this thing called psychrometric complexity, and what this is a summary of psychrometric complexity is a measure of the number of paths or potential paths through some code. So psychrometric complexity of 0 means that essentially there's just, well, in this case it's 0 because there's no paths through the code because the code's an empty file. And we'll see here that's complaining. It's giving you a violation of there's no code in it. But we'll get into violations in a second. So this psychrometric complexity of 1 means essentially there's one path through the code. Psychrometric complexity of 2 we'll try that. Psychrometric complexity of 2 means there's 2 paths through there. Now that's maybe not a good example. We'll pick another one. Okay, this is saying a psychrometric complexity of 4 because there's actually 3 modules, three functions. And this psychrometric complexity is being measured against the file itself, not a particular individual function. So this is probably a better example here. So what we're saying is this one's got a fairly high psychrometric complexity, and it's got a high complexity because what we have here is a number of different paths to the code. So we've got one path which is your default execution path, and then we can see here we've got a loop. So we've got whether or not you enter the loop or not is a condition. So that would be a complexity of 2 because there's 2 paths through the code, in the loop or not in the loop. You've got an if case within a loop. So what that's saying is that now there's an additional path through the code. You may not go into the loop. If you do go into the loop, you may or may not go into the if condition, and so on and so forth. So you've got an else if condition with an else, and that's an additional complexity. So what we're saying is this is the most complex piece of code as far as the number of paths that we need to understand, the number of paths we need to test. Does anyone have any questions before I move on to the next? Just rush through the next few metrics. Okay, string manipulation load. So we're talking about there is how many string functions are in our code. So how many lengths, how many substrings, because they can be potentially a bit of a performance issue and create a bit of memory. And then the weighted string manipulations load is trying to measure. We're trying to look at where, So weighted string manipulation code is trying to differentiate between where, say, you have lots of different string manipulation, but it's only going through one path, versus a bit of string manipulation, but it's in a combination of loops. For example, a while loop with another for loop. That would indicate that you actually may be doing a lot more work than you might necessarily need to be doing if it was done outside the loop. So that's violations, and there's a bit of information in the, or have a bit more information in the documentation or the manual, which you can download from the website about what they actually mean and what they can be useful for. The next, metrics. The next bit we're going to talk about is issues, and issues is probably the thing that most people are interested in this product and most interested in Sonar. So issues is trying to tell you where you have a potential problem or a known problem, where you've deviated from a coding standard. And issues are also called rules. We can see here the easiest thing is to go into our rules, and this is a list of rules that the product actually implements. So there's various things in here like unused variable and the XSL style sheet. In this case here, we're talking about a variable is used but not declared, so it will work, but you'll always have null. An XSL variable is used but not declared. For message broker, an XSL variable choice, XSL chooses missing a fall through, XSL otherwise. So basically, it could be an XSL, look for an XSL if, or it could mean that you're missing a logical condition. Avoid using double backslash in path because it repasses from the root of the document. Avoid using cardinality in loops because it breaks, it doesn't perform all that well. Naming stands around queues. This one here is saying the queue name and the backout queue name that matches it from the MQSC file don't correspond to this particular pattern. This is something built for a particular customer because they wanted the naming convention a certain way. So all these rules can be turned on and off in something called a quality profile. And then a quality profile is basically a list of rules. In this case here we've got a profile which has got all of them, and then that profile itself, those rules themselves have a severity, and so you can tune the severity and the particular rules you've got on. So we'll jump into some rules, and we'll jump into some. We'll just jump in and show some of them. For example, cardinality in loops, which we've said is a major blocker issue or a major. In the default profile, it's major, and another profile it looks like it's a blocker, and another profile it said is major by default. So we'll see. Look, if we see here, we've got in these 4 files, we've got this particular, in this 4 files in this particular project, which we've analyzed, we've got this issue occurring. So if we go into our piece of code, we can see here that it's telling us avoid using cardinality in loops, and it tells you which file it's in and where in the file it is. So this file itself doesn't have, and you drilled on this particular issue. So if you looked at this file through other menus, you get slightly different issues. So we'll go back to our demo, and we'll look through our issues. And there's a lot to go through, but let's we'll just pick a few just as a demonstration. So no broker schema defined. So we pick this particular file, and we can see here there's a number of violations against this file. So we've said that there's no broker, and we're using a default broker, and we've got a rule that says you don't want to do that, which is default schema. We're saying that we've no comment block, so we're not commenting this file. We're also saying, well, this file is kind of useless because there's nothing in it. And we've also said this file's got nothing in it, it should be removed. Or ESQL has been commented out and should be removed. So because you've got ESQL code which shouldn't make up a comment, in difference to a comment which helps describe the system. And then you've got some more comments around well, you want another issue around you want what you want in the header, not that you don't just have one. So in this case, this is saying that you want to have the company name in the header, and you also want the version, author, and date. Oops, so going to our issues. So we can pick some more. So we've got some things around here. Compute node is message, but the message is never read or written. So if we look here at this particular compute. So what we're saying is we've got a compute node. We've got a compute node that said pass the message in and pass the message out, but we're not actually creating a message on the way out. So basically, we could just, it looks like this compute node could sorry, apologize for that, something's going on there. Classification, and some of these particular ones that may not make a lot of sense, but they're actually been written for particular clients. So we've got a client that says we want to have particular types of message events, or particular monitoring events, I should say, attached to particular types of nodes. If that node doesn't have this particular monitoring event, we want to tell the developer to go add it. In this case, again, here there's naming standard around the event trigger. We've got input notice no fail handler. So if you decide that every node should have a failure process, otherwise it doesn't conform to standard. And you can also have every node should have a catch handler, or you could say it's also possible to add a rule that says you shouldn't have a handler because you want to default to the broker rollback and putting the message in the dead letter queue. So that's violations. So as I said, we do have a lot, and so when you're running against this code, so for example, a common one might be unused variables, fairly common one to most programming languages. So we can see here that we've got some examples here where we've got some variable defined. So we've got a total length of variable defined, max total length defined. It's not actually used anywhere in our code in this particular routine. It's not declared, as I guess it's a more global level. So we're saying, well, it's not declared, it's not used, so it just adds confusion, and we could actually remove it from our code because A, it's confusing, and B, it's potentially a performance issue. Yeah. So that, yeah, another example of some common violations. So that's violations. We'll go back into our project. The last two we'll show on the dashboard. Actually, won't show on this dashboard. Actually, we'll show on this dashboard is duplications. So duplications. There's a duplication detection. So which we can jump into here, and this gives a bit of information about what's duplicated. So, for example, in references, SQL. Now, the duplication you do have to take with a bit of caution, because it's quite possible that the code of this duplicate might be something that's actually generated the copy message header sort of code, which you probably wouldn't want to mess with too much because it just makes it confusing for people. But we can see here, so this case here, we've got a whole block of duplicated code, like the whole file looks like it's duplicated, and we can see here, we click on the duplication toggle. When it loads up, it will actually tell you where it's duplicated. So looks like we've got two copies of the same file: broker references, broker util references, and generic references. So we've actually got large blocks of the code duplicated. In this case here, we've got test flow. So we'll go from the duplications. So it looks like we've got this block of here, test code here, which is got sort of if condition. And we're saying this particular if condition is duplicated somewhere. We'll just wait for it to load up. Does any questions just while this particular one loads up? Seems to be quite, causing my machine some issues. Yeah, so we're saying here that this particular block of code is duplicated. It should tell us where, hopefully. And it's duplicated in this file, line 251. So we've got this block here. If we go down to line 251, it looks like you've got the same if check. So you've got a duplicated piece of code in the duplicate piece of code in the same file, essentially. So that's code duplication. And the last one, sorry, and there's only one project that I actually have this enabled for, is unit test coverage. So basically, unit test coverage, what we do is for this is we generate what we call a coverage XML file, or a generic coverage XML file, which we plug into Sonar. And we generate it with you can generate with an Ant script, or we just develop some Java classes to do it as well. And if need be, if someone wants it, we can probably look to wrap this up as a Maven task. But essentially, it's a build script that says I want to take a bar file that's been configured a certain way, or built a certain way, mostly with the deploy source turned on. I'm going to unzip that bar file. I'm going to instrument all the ESQL and message flows in a particular way in that bar file. I'm going to zip it back up, allow you to deploy it to a test environment. Once you've deployed it to a test environment, when particular pieces of code in that bar file execute, we'll actually trace out to something called the trace into the test listener, and which will start up here. Which we start further up in our Ant script. We then have something called the listener, which we run on a port, and what it does is it reads a file called it generates a file called the coverage temp file. Sorry, it reads the instrumented file that the instrumentation built called coverage in the coverage temp directory. It then listens for messages from the running broker about what tests and which lines have actually been executed and how many times. Then it records back that coverage file with information about what lines, how many branches, and what branches have been covered. We then take that file and we run our analysis with that file set up. And that gives us the coverage report. So at the moment, the coverage is based around only what it can recognize as deployed. So if the file's not listed, it basically means it's got zero coverage, or it's fully covered. It's a little bit confusing. In this case here, we've got a flow that says that has been deployed. And we're saying it's been deployed, but it's never been executed. So we haven't triggered this flow as part of our test cases. So the whole thing is just said as haven't been deployed. So it's not as granular on the message flows at the moment. It's basically a yes or no for message flows, whether it's been run or not. So we go to coverage here. So in this case here, we've got two coverages. We've got test4 log, and we're saying that flow is actually tested, and we've got a test backlog should reply, and that has not been tested. Covered, false. So that one's not covered, this one here. So we're saying this ESQL file here. What we're saying is this looks like this code is partially tested. So it's got 56% coverage. So of the lines, so we're saying it's the actual thing's been started. So it's been called, this particular routine. There's an if condition that's been partially tested, in which case it's been tested. That particular branch of the if condition hasn't been tested. This else condition has been entered. The if condition of the else hasn't been tested. Oh, sorry, the if condition of the else hasn't been executed. So this particular branch here hasn't been tested. We have another if condition, say this if condition was tested. Within that if condition, we've got a branch that says only one condition was tested, in which case this was the path here that was executed. So we can see that, which parts of our code essentially have been covered, which haven't, and we can sort of look to improve that metric over time. So that's the coverage component. Does anyone have any questions before we jump in the last few minutes to the diagrams? Right, I'll keep going. So what we've developed here is we've taken all our different file types, so message flows, subflows, ESQL files, XSL files, MQSC files, map files, and occasional Ant script file. We've merged all this information together to give us violations and metrics and all this information about our project. What that means is in memory, when we've done this analysis, we've got all this information available. So what we thought was the obviously next extension, and something that would hopefully be useful to developers if we've started developing, we developed a diagramming component. So what that diagramming component is configured here in the properties file, but basically it says go generate a diagram, the diagram information about everything you can tell me about the project into this folder, which you can then publish using WebDAV or SharePoint or Confluence or however you feel like publishing it. What I have here is a little what's called a Mongoose server, and my Mongoose server here is looking at one of the directories, in this case here, the coverage one. So I'll just show you two different diagrams here. So one is quite a large project, what our broker demo, which is a bit of a fictitious project, but hopefully gives you an idea of what it would look like for a real project. And what we can see here is these boxes here are flows. And in this case here, we can see that this particular message flow, message to email, is triggered by a message coming in the in queue. And this, when a message goes to the in queue, it goes to this message to email flow and triggers this message to email flow. What we can do is we can export that as a JPEG file, and that way we can put in documentation, for example, or export as a PNG file. In fact, this whole diagram here exports as a PDF, a JPEG file, so that we can see here. So this might be a bit clearer to see. So we've got here queue means that this flow is triggered by a queue, or writes to a queue. In this case, it looks like it writes to a queue, or writes to two queues, drawing 1 and drawing 2, and drawing 4, drawing A. What we can see here, this drawing 1 flow is triggered by a message from drawing 2, display all calls, which also then potentially triggers 3 different flows, log, drawing, and drawing 4 and drawing 3. We can see here that drawing 3 is either triggered by or either reads or writes to a file, to the file system. We can see this drawing circular, this particular flow reads to a queue, which it writes to itself, which may be a good architecture decision or not, but at least gives you a bit of information about what it's doing. And if it does start causing issues, you can look at why it might be doing that. So that's the generated JPEG diagram. So we can jump into these particular flows and we can see a little bit about them. So we can say it's consuming a message from this particular queue and writing it to another message to another queue. So this information gives us a bit more of a business logic flow or a business process flow about how messages and communication around our flows work. Otherwise, if you're just looking at it through the developer tool, you can be working on a flow, but you've got no real context of where that sits in the process or in the world of your company. And this gives us a bit more context around that. So that is the flow summary. What we've done then is we've taken the flow summary, we've extracted out all the comments, and we've published the comments into a page. So what we can do is here we can see what sorts of things about our flows there are. So this tells us a little bit about our flow. And it also tells us the subflows that are children to it. We've got a queue summary and tells you what queues trigger what flows. And we'll just make this extended. So some of these are empty. And that's because what we've said here is this particular queue doesn't look to be used by message broker, but it's purely only used by, looks like by data power. So we've got a queue here that data powers reading or writing to. Looks like data power is writing to. So if that same queue has been written by data power but read by broker, that will show up here. We've got SQL statements, what we've done here is we've attempted to extract all the SQL. So it's the same SQL that we use in our checks. So one of our checks is to pull out the SQL, check to see whether or not that particular table can be reached or is available in the schema, and then go through the columns that are defined in here in this generated SQL to say, well, does that is that particular column available? Is that particular column available in the table? And give us a warning back to say, well, I found you your table, but I can't find one of the columns that you're referring to, or I found you a table, and one of the columns that you're selecting by isn't an indexed column. So you might want to make sure there's at least one index on these selects, and that's gives us a little bit of runtime checking as well. So what we've done is we've extracted from the original SQL what we think or we expect the broker to run, and done some checking around that. And what this means is you can give this tool, or you can give this documentation, or link to this documentation to your database administrators, and they can have a bit of a poke around and see what sort of SQL is being run, and there's anything that they don't like. Data source is just a summary of the data sources in the project. Properties, just a summary of properties in the project. All the SQL modules is what we try to do is we try to pull out what we think of common code. It looks like it doesn't belong to a single file. It might reference in multiple places and sort of build up a library of things. So ideally what we'll do is, as the analysis runs over your code, we'll try and pick up as much of code that it thinks is like a utility method or a procedure to be used in lots of places, so that new developers or people that need to find particular bits of code, not quite sure what it might be called, can look in here and have a bit of a guess about what some of these might be useful for, or where they might want to make use of a function or manipulate an existing function. All Java methods, so where we're calling Java from. Stored procedures we're calling, where they're called from. Events, again related to nodes. All input files, so which files are being read, switch flows are reading files. In this case, we don't know what the file name is called, but we can see that's writing out a file. In that case, so we're saying, so files being written, where they're being written to, incoming URLs that flows might be listening to. So we see here we've got a flow that listens to a particular URL and triggers this particular URL, triggers this particular message flow. So again, so we actually see here we've got two flows that are trying to listen to the same URL. So what we might have is exactly what will happen at runtime. We're not sure. These might be in two different execution groups and maybe not turned on at the same time. We're not sure. But it may be a design issue where we've actually got processing the same thing two different ways. Output URL, so basically where the broker is going out to something, we've tried to identify it. So if you need to know what's where in the broker, something else triggers something else, hopefully you can look in here and it'll give you a bit of an idea. Just a summary of the exceptions, descriptions, just if you want to standardize them. Data put input, data put output, so where data power is calling out to something, which is the data power file that's doing it. Sterling information, so about processes and locks. So that's the high level view of the detailed level view of what's in the document, in the diagrams. The other diagram we're going to look at here is the coverage one, which is this is a slightly cut down project, which is just focusing on just the coverage, code coverage, who we're looking at before. So this takes in the two. This project has been analysed and taking the two, I guess, dynamic or runtime files, which is the code coverage, and something that we've called execution group runtime information. So what we've got here is we've got a setting that says use the coverage file and the runtime file. And the runtime file basically is some information about what execution groups with information that we've extracted from the broker runtime, say what execution groups are in which broker and which flows in which execution groups. So in this case here, we've got a runtime file. Inside that runtime file, we've got some information about the execution group and the flows in it. So what that means from a diagram perspective is we can take the information and draw it out with the intention that we will merge that information about execution groups and flows with other information that we're actually in the process of processing or generating, called the template. And what that will do is, what that will mean is you as an architect or developer will fill in the template according to what you think is important about what sort of rules or which execution groups should be accessing the file system, for example, or which execution groups should be available to go out to make SOAP calls out, which execution groups should be listening to SOAP calls coming in, and then other rules like whether or not you want all your MQ, all your flows that read to consume MQ messages, whether you want them for reasons of load balancing, whether or not you want them duplicated in all your execution groups, for example. And so what we've got here is a little test box. So what we've said, we've taken our code coverage information and we're mapped it on top of our generated diagram. And so we can see here we've got of the 7 flows that we've set here, one of them has actually been triggered by our test cases and the other 6 haven't. So if we're looking to improve our test coverage, this is a good tool for seeing what's happening, because we can see that we've got no test coverage on these particular flows, and one flow test has got test coverage. So if you're going to get a new developer to write a test to cover a piece of functionality, you can say, well, look, this particular flow is important and hasn't been tested, so let's write some tests for it. See if we can make sure it's executed and run. So that's including the test information in the diagram. The next bit of information is we've overlaid the flow details with the execution group. So we can see here that we've said we've taken the runtime information and the static code analysis, and we can see that this particular flow is deployed to 2 execution groups. This particular flow is deployed to no execution group. So this is something that we might want to flag. So either this might be something that is not supposed to be a real flow, it might particularly be only for testing, which is valid. And we might be putting in a production-like execution group or runtime environment, or otherwise we might be having one of those snowflake environments where this should be deployed somewhere but isn't, because it's new or hasn't been included in the deployments in the automatic deployment script. In which case we can go back to a developer and say, please include it in the automatic build script because we want it being deployed. And again, here we might say, well, this particular flow is important, so maybe it should be 3 execution groups, not 1 execution group, or 2 execution groups. And then what we've got here is just a diagrammatic representation. So we've got this particular execution group has got 2 flows, and we can see highlighted there that those 2 flows are in the same execution group. Probably in this example is a bit contrived, but imagine that we had something that looked more like that. Being able to see which ones are in which execution groups could be quite handy to us and useful. And again, Snowflake setup. So we've got here, we've got that particular execution group has got 1 flow. This particular execution group has got 2 flows, and I think one of them actually has 3 flows. 1, 2. But what we can see here is we've got an execution group with 3 flows in it, but only 2 of them come from our source code. So this might be another indication that we've got bad configuration, because we've got flows that don't look like that are not part of our source code. So it could be that they're actually legitimately from another source code repository, but it could just be that they're still running, but they may have been deleted and they're not supposed to be there. So again, this might be an indication for our developer to go in and update our build deployment script so that the number of flows matches to what we expect in the code. So we're coming up to the end of the hour. I know there's probably a lot to go through. Hopefully I hadn't gone too quickly. Hopefully it's been useful and entertaining at least. And hopefully it gives you some food for thought. So if you do have any questions, please feel free to reach out to us, either via our contact page at our website, bettercodingtools.com. We also have an online chat functionality now, which sometimes doesn't work. But we have an online chat functionality where which in theory you can chat to. Hi. Otherwise, or reach out to me at my email address, which is richard@bettercodingtools.com. Yeah, if you have any questions, feedback, or advice, please feel free to reach out to me. Otherwise, I'll let you get back to your day. Hopefully you've enjoyed this presentation, and I will chat to you later. Thank you for your time.